Have you ever looked up at the night sky and wondered what's out there? Beyond the familiar moon and stars, our solar system is a bustling highway of cosmic travelers. Among them are comets, those icy wanderers that occasionally grace our skies with their spectacular tails. Today, we're diving deep into the story of one such comet, a celestial object that promised a show for the ages, delivered a cosmic drama of a different kind. We were talking about Comet C, 2019 Y4, better known as Atlas. So, what was Comet Atlas? And why did it capture the imagination of astronomers and stargazers worldwide? Discovered on December 28, 2019, by the Asteroid Terrestrial Impact Last Alert System where the name Atlas comes from this. Comet was initially just a faint smudge in the constellation of Ursa Major, but it wasn't just any smudge. Astronomers quickly realized its orbit was incredibly similar to the Great Comet of 1844. This was a huge clue. It suggested that Atlas was likely a fragment of a much larger parent comet that broke apart centuries ago. Imagine finding a long-lost sibling of a famous historical figure. That's what this felt like in the astronomical community. The excitement began to build. Early in 2020, Comet Atlas started to brighten at an astonishing rate. It was getting brighter much faster than anyone predicted. Projections were flying around, and some optimistic models suggested it could become bright enough to be seen with the naked eye, maybe even rivaling the planet Venus in brilliance. Social media was buzzing with the hashtag Comet Atlas. People were getting their binoculars and telescopes ready for what was being hyped as potentially the comet of a generation. The stage was set for a celestial spectacle in the spring of 2020. Now, let's talk about why this rapid brightening was so exciting. Comets are essentially giant, dirty snowballs made of ice, dust, and frozen gases. As they approach the sun, the heat causes these ices to sublime it, turning directly from a solid to a gas. This process releases dust and gas, forming a glowing atmosphere around the comet's nucleus called a coma, and the iconic tails that stream away from the sun. A comet that brightens quickly, like Atlas did, suggests it's highly active. This could mean it has a lot of volatile material just waiting to erupt into a brilliant display. Everyone was watching, holding their breath. Would it live up to the hype? Would it become a glorious beacon in our night sky, a once-in-a-lifetime event? The anticipation was electric. Every new observation was scrutinized, and every new image shared widely. We were all ready for the big show. But, as we all know, space is full of surprises, and Comet Atlas had a major plot twist in store for us. Just as the excitement reached its peak in late March and early April 2020, something unexpected happened. The comet's brightening suddenly stalled. Then it started to fade. Astronomers around the world turned their powerful telescopes toward Atlas, trying to understand what was going on. Was it just taking a brief pause before another outburst? Or was something more dramatic unfolding millions of miles away from Earth? The first hints came from amateur astronomers, the dedicated backyard observers who often spot details the big surveys might miss. They noticed the comet's central core, its nucleus, was looking elongated and fuzzy, not the sharp point of light it should have been. It was a telltale sign of trouble. The comet wasn't just fading, it was falling apart. Confirmation came swiftly. The Hubble Space Telescope was pointed at ATLAS, and the images it sent back were breathtakingly clear and undeniably sad. For those hoping for a bright comet, Hubble saw not one, but a cascade of smaller, icy fragments. The solid nucleus that had traveled for centuries through the cold, dark depths of space was disintegrating. It was like watching a beautiful ice sculpture melt and crumble just before the big exhibition. The comet had broken up. So, What causes a comet to disintegrate like this? There are a few likely culprits. One major factor is tidal forces. As the comet gets closer to the massive gravitational pull of the sun, it can be stretched and pulled apart. Think of it like pulling on a piece of taffy until it breaks. Another reason could be its own internal activity. The rapid heating from the sun can cause pockets of frozen gas to burst out violently, like a volcanic eruption. If these outbursts are strong enough, they can shatter the comet's fragile nucleus. In the case of Atlas, it was likely a combination of these factors. Its rapid brightening was a sign of intense outgassing, which may have destabilized its structure. It was a fragile comet to begin with, likely a piece of a larger body that had already broken up long ago. It seems this family of comets is just prone to falling apart. The very thing that made it so exciting, its explosive activity, was also its undoing. It was a classic case of flying too close to the sun, both literally and figuratively. The disintegration of Comet Atlas wasn't a failure, though. It was a scientific gold mine. Astronomers got a front row seat to a process that is fundamental to the life cycle of comets. We rarely get to see a comet's death throes in such incredible detail. The Hubble images provided invaluable data. By studying the fragments, how they moved, and how they continued to sublimate, scientists could learn more about the internal structure and composition of comets. It was like being able to perform an autopsy on a celestial body. We learned that the nucleus wasn't a single, solid, rock-hard object. Instead, it was likely a loose collection of smaller icy chunks, a rubble pile held together by weak gravitational forces. When the solar heating ramped up, it didn't have the structural integrity to hold itself together. This observation supports a leading model of how comets are built. Furthermore, studying the breakup helps us understand how comets contribute to the dust in our solar system. Those beautiful meteor showers we see, like the Perseids or the Geminids, are caused by the Earth passing through the dusty debris trails left behind by comets. The death of Comet Atlas created a new, fresh stream of dust that future scientists might be able to study. So, while we didn't get the dazzling naked-eye comet we were hoping for, we got something arguably more valuable, a unique window into the violent and beautiful mechanics of the cosmos. The story of Atlas is a perfect example of how, in science, even an apparent disappointment can lead to profound discoveries. It's a reminder that the universe doesn't always perform on cue, but it always has something to teach us. So, what's next? What's going to happen with the remnants of Comet Atlas? Well, the ghost of Atlas continues on its path. The cloud of fragments has spread out and continued to fade as it moved through the inner solar system and is now heading back out into the cold depths of space. It won't be a spectacular sight anymore, just a faint, dispersed cloud of debris that is mostly invisible to all the most powerful telescopes. The orbit of this debris cloud is well understood. It's on a very long, elliptical path that will take it far beyond the orbit of Neptune, out into the Oort cloud, the distant reservoir of comets. It will be thousands of years before what's left of Atlas returns to the inner solar system. By then, it will likely be even more spread out and even fainter. We, in our lifetimes, will not see it again. But the story isn't over. Remember that Atlas was a sibling of the Great Comet of 1844? That means there could be other fragments of that original parent comet out there on similar orbits waiting to be discovered. Astronomers will be watching that patch of sky very carefully in the coming decades. Who knows? We might one day discover another Comet Atlas B that could hold together and finally give us the spectacular show its predecessor promised. The tale of Comet Atlas is a beautiful lesson in cosmic perspective. It's a story of high hopes, a dramatic twist, and incredible scientific discovery. It reminds us that the universe is a dynamic, ever-changing place. It's not just a static backdrop of stars. Things are born, they live, and they die, even on a cosmic scale. While we may have missed out on a bright light in the sky, we gained a deeper understanding of these mysterious icy visitors from the edge of our solar system. And that, in its own way, is just as spectacular. So, keep looking up. The next great comet could be discovered tomorrow, and its story is just waiting to unfold. Thanks for joining me on this cosmic journey today. If you enjoyed this deep dive into the life and death of a comet, make sure to hit that like button and subscribe for more adventures into the universe. Let me know in the comments if you remember the hype around Comet Atlas. Until next time, stay curious.